All right, guys, are there any questions on any of the assignments so far?
How did I get 100? That's my question. What other 100? Yeah.
Any questions on any of the homework assignments so far?
Oh, yes.
Before we start 4.6. Because we'll probably have time at the end of the hour. If we want to go over them, then we can too. So, the first thing we have is this here, the fundamental theorem of algebra. The table shows several polynomial equations and their solutions, included repeated solutions. Notice that for the last equation, the repeated solution, x equals -1, is counted twice. So when we look at these three here, so the top one, 2x minus 1 equals 0. The degree is 1 because the biggest exponent is 1. The solution is 1/2, and the number of solutions is 1. The next one that we have, x squared minus 2 equals 0. The degree is 2. Our solutions are plus or minus the square root of 2, and the number of solutions is 2. And the same thing for our next one, x cubed minus 3. There you go. Our solutions are 2, -1, plus or minus I squared of 3, but we do have a total of 3 solutions. And our last one, x cubed plus x squared minus x minus 1 equals 0. The degree is 3. Our solutions are -1, -1, and 1. And the number of solutions is 3. Now, what this all leads to is something called the fundamental theorem of algebra. Fundamental theorem of algebra. So you'll need a note sheet. Okay? Now, the first part of the theorem is if f of x is a polynomial function where degree n, where n is greater than 0, then the equation f of x equals 0 has at least one solution in the set of complex numbers. So that means one of our solutions is a complex number. And we've seen many equations where, well, our solutions would say x is equal to 4 and 5. Now, neither one of these numbers is technically a complex number, 4 or 5. But we can make them be complex numbers. We can write above it, x equals 5. Because for it to be a complex number, it has to have an I term. So I can make any number a complex number because 0 plus 0 I to it. We can add I. So x equals 5 is going to be the same as x equals 0 plus I. So it's still a complex number. Now, the corollary from this, if a polynomial degree n, where n is greater than 0, then the equation has exactly n solutions, provided any solution that is repeated is counted multiple times. So if a solution is repeated twice, it's counted twice. If a solution is repeated 3 times, it's counted 3 times, and so on and so forth. So the degree will give us the number of solutions every single time. Questions on this here? So, how many solutions does this equation have? Because it does have 3 solutions because the degree for this polynomial function is 3. Now it works out that the solutions for this are -3, 4i, bless you, and -4i. Those would be the 3 solutions. Let's look at the next one. How many zeros does this function have? Because degree is. You're good. Now the solutions for this here are -2, -2, -2, and 0. So I'm showing you those solutions so you kind of know what they are, but there are 4. 0 is a solution that works for this here. Because again, we're looking for what values of x will make the function be 0. And if we look at this one here, x to the 4th plus 6x cubed plus 12x squared plus 8x, there's no constant term. So plugging in 0 for x would make everything 0, so it is a solution. Questions on this here? How many solutions does this equation have?
4.
Because the degree is 4. I think we feel pretty comfortable with this so far, yes? So, when we look at this one here, we want to find all zeros. We want to find all the zeros for this function here. How many zeros should we have? 5. Now, again, what we can do first is graph it. Because if we graph it and find 5 nice numbers, then we are done. So here, we can pull the graphing calculator up, hit y equals, and we will have x to the 5th. Plus x to the 3rd minus 2x squared minus 12x minus 8. Now the first thing we can do is type this in and graph it. Now this here is the graph that we have. Now it didn't give us 5 nice solutions. It gave us 2, at least 2, because depending on how it intersects the graph at -2. And we look at the table, or not -2, -1. So way 2. So at -1 at 0, and at 2 at 0, yes? And with a degree 5, if we can find at least 3 solutions, we can get it back down to a quadratic. So the first thing we can do is set up our synthetic division. And across the top, we would have 1 for x to the 5th, and then 0, because we don't have an x to the 4th term. 1 for x cubed, -2 for x squared, -12 for x, and -8. Now the first number that we can try is -1. Now -1 times 1 is -1. 0 plus -1 is -1. -1 times -1 is 1. 1 plus 1 is 2. -1 times 2 is -2. -2 plus -2 is -4. -1 times -4 is 4. -12 plus 4 is -8. -1 times -8 is 8, and -8 plus 8 is 0. What's the next number we can try? Two. So we can try 2 next. And we know it's going to be 0 because the graphing calculator told us that when x is 2, the y value is. So we can do this here. 1 times 2 is 2. -1 plus 2 is 1. 2 times 1 is 2. 2 times 2 is 2 times 4 is -4 plus 8 is 4, and 2 times 4 is 8, which gives us a 0. Pull the graphing calculator back up. Now again, we talked about this and mentioned this a few times, that anytime the graph crosses the x-axis or hits the x-axis but doesn't cross it, there's a good chance it has an even multiplicity. So the number of zeros there could be more than 1. And if we look at this here at -1, does it actually cross the x-axis? It doesn't look like it could, but it doesn't look like it does. And anytime we have that, we can always try that 0 again. So negative 1 times 1 is negative 1. 1 plus negative 1 is 0. Negative 1 times 0 is 0. 0 plus 4 is 4. Negative 1 times 4 is negative 4, and 4 plus negative 4 is negative 1 came up twice. Because anytime it doesn't cross the x-axis but does intersect, hit it, it's going to have an even multiplicity. It's going to show up more than once. And at this point here, we can plug our variables back in. So this is our remainder. 4 is our term without x. 0 is our term with x, and 1 is our term with x squared. So what we have left is x squared plus 4 is equal to 0. So far we've found 3 solutions, yes? Negative 1, and 2. What we have left is a quadratic, x squared, yes? How many solutions is it going to have? 2, because the degree is 2, yes? Now at this point here, we can solve this by the quadratic formula, or we can use the square root method. Because is there a middle term? Is there a term with just x? Well, no. So whenever there's an equation without a middle term, we can use the square root method. So we'll get x squared by itself first. So this tells us x squared is equal to negative 4. Then what do? Square root both sides. Square root of x squared is equal to plus or minus, because anytime we take the square root of both sides, we have to add the plus or minus. So we're looking at the square root of negative 4. Well, the negative is going to come out as, which leaves what? Square root of 4. And what is the square root of 4? So our other 2 solutions are plus or minus 2i. So if we listed out all the solutions, it'd be x is equal to negative 1, 2, and plus or minus 2i. So how many solutions do we have total? 5, yes? Do we have all 5? Yeah, we have all the solutions because the degree was 5. We needed 5 solutions, and we do have 5. And that's it. Questions on this here? Now, I will show you this here so you've at least seen it. X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Now it is possible to solve this with the quadratic formula because we don't have a middle term, so the value b is 0. So what we're saying if we plugged it in is negative 0 plus or minus the square root of 0 squared minus 4. Well, a is still 1. C is 4 over 2 times 1. So what we have here, x is equal to 0 plus or minus the square root all over 2. In the calculator we can do this because it'd be 0 squared minus 4 times 1 times 4 is negative 16. And yes, that is a little different than what we got, but it'll still work out because we have 0 plus or minus. And negative is going to come out as I. Square root of 16 is 4. Well, 0 plus 4i and 0 minus 4i, it doesn't add anything, so really what we have is plus or minus 4i over 2, but 4 over 2 is 2i. We get the same thing. Square root method's a little bit faster, a little bit easier to work with. Any questions on this here? Let's look at the next one. X cubed plus 7x squared plus 16x plus 12. How many solutions do we want at least? How many is the minimum that we want? Because 2 would be really nice. What would be really great is 3, but we need at least the smallest number I could have. 1, because if I have one solution, we can take it from a degree 3 down to a degree 2. We can solve a quadratic. If we have 2, we can take it from a degree 3 down to a degree 2, down to a degree 1, and solve from there. But again, how many solutions are we looking for? 3. It's got to have 3. But again, the first thing we can do is take the graphing calculator and graph it. So we can say x to the third plus 7x squared plus 16x plus 12. And we have this here. Now it does look like it intersects the graph there, so second graph. So how many solutions do we have for sure? 2. Could one of those have an even multiplicity? Possibly. Now, we don't see that it intersects the graph anywhere else, does it? So that could mean that we have complex solutions. We have solutions with I, but not likely. Because how many solutions did we find? 2. How many are we looking for? 3, yes? If we do have a complex solutions always come in pairs because of our complex conjugate theorem. Because if we have A plus BI as a solution, A minus BI has to be a solution. They always come in pairs of 2. Same with complex numbers. They always come in pairs of 2, which is good to know. Because here, I know that I have 2 solutions and we only are looking for 1, yes? If the other one was complex, it needs a pair. So that means the other solution can't be complex or irrational. Because if it's irrational, I need 2. If it's complex, I need 2. We only have 1 more. It can't be irrational, it can't be complex. Does that make sense? Because we would need 2 more for it to be either one of those. So we can come back over here and do synthetic division. Now we'll have 1 for x to the third, 7 for x squared, 16 for x, and 12. And our first solution that we can try is -2. Yep, just making sure. Now -2 times 1 is -2. 7 plus -2 is 5. -2 times 5 is -10. 16 plus -10 is 6. -2 times 6 is -12. Hopefully y'all feel pretty comfortable with synthetic division by this point. Hopefully those will be easy points on the test. Doing these here, fingers crossed. Because the biggest thing is making sure that you do put your zeros in to where they need to go. Now the other one we had was -3. -3 times 1 is -3. 5 plus -3 is -3 times 2 is -6, and 6 plus -6 is 0. Now, definitely if you get down to a quadratic and you don't have any solutions left, you want to use quadratic formula to find the rest. But if we have, so here we had 2. I could have stopped after the first one, but if I already have another one, let's go on and do that. Because what that gets us down to, this is a remainder. 2 is our term without x. 1 is our term with x. So our final, what we have left over is that x plus 2 equals 0. Because if I can get it down to a linear equation, that makes it even easier to solve. Because at this point here, all I need to do to solve this is to subtract 2, telling me x is equal to -2. So our solutions for this are x is equal to -2, -2, and -3. So it did kind of confirm that at the point where x is -2, it touches the x-axis but doesn't cross it. And that's it. Questions on this here? Any questions on anything we've done so far? Find all the zeros for this polynomial function. So again, the first thing I would do is graph it. X to the 5th minus 3x to the 4th plus 5x to the 3rd minus x squared minus 6x plus 4. And graph it. So we do have some places where it crosses, or we do have some zeros. So if we go second graph, we have zeros at -1 and 1. So we can set this up: 1 for x to the 5th, -3 for x to the 4th, 5 for x cubed, -1 for x squared, -6 for x and 4. And I just picked one. We didn't have, really doesn't matter if we use 1 or -1 first. We just need to pick one of them to do first. And we could go on and do this here. -1 times 1 is -1. -3 plus -1 is -4. -1 times -4 is +4. 5 plus 4 is 9. -1 times 9 is -9. -1 plus -9 is -10. -1 times -10 is +10. -6 plus 10 is +4. And -1 times +4 is -4, or 0, not -4. -4 plus 4 is 0. Questions on this so far? So what number can we do next? 1. 1 times 1 is 1. -4 plus 1 is -3. 1 times -3 is -3. 9 plus -3 is 6. 1 times 6 is 6. -10 plus 6 is -4. And lastly, 1 times -4 is -4, which does indeed give us 0. So what's the degree of our polynomial at? 4, well, 3, yes? So we need to get it one more. What other number could we try? Let's look back at the graph. At -1, it definitely does cross. Does it cross at 1? Does it cross the graph at +1? Possibly, possibly not. Let's try it again. Let's try +1 one more time. Because if it doesn't cross, it's going to occur an even number of times. So 1 times 1 is 1. -3 plus 1 is -2. 1 times -2 is -2. 6 plus -2 is 4. 1 times 4 is 4. Well, that did work. So we had one more solution of 1. And at this point here, we can stop because we're now down to a quadratic. 0 is our remainder. 4 is our constant term. -2 is our term with x. and 1 is our term with x squared. So what we're left with is x squared minus 2x plus 4 is equal to 0. Now we didn't see anywhere else that it did cross. So most likely these here are going to be complex terms. But to solve this, we can use the quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. Now if you need to, or if it is helpful, to write a, b, and c on top so we know what they are. So the first thing we have is negative b, which is going to be what? Negative 2, yes? You're welcome. So here our first thing is negative b, yes? Well, what's the value of b? Negative 2, yes? Well, we can do, at this point, I think y'all feel pretty comfortable saying negative 2 is just 2, yes? Even when I do these myself, I will go on and simplify that, negative 2. It's not too bad saying, okay, negative make it positive. The denominator is 2 times a. What's the value of a? 2 times 1 is what? 2. Even if a is not 1, because even if it was, say, 4, well, 2 times 4 is 8. I feel comfortable doing those two in the same step. I still leave negative 2 squared minus 4 times 1 times 4. I still leave that where it is. Because switching a sign from positive to negative, positive, that's not too bad while we're plugging everything in. Multiplying by 2 is not bad. Doing all of that with everything else is a bit much. Now at this point here, we can plug it in. So we can say negative 2 squared minus 4 times 1 times 4 gives us negative 12. So what that tells us is that we have x is equal to 2 plus or minus the square root of negative 12 over 2. Now, if we'd have plugged the square root with that into the graphing calculator, it would have given us a decimal or thrown out an error, depending on if it's an a plus bi mode or not. But now that we know that's the square root of negative 12, well, the negative is going to come out as I. Now we can use the 30xs to take the square root of 12. The yellow calculator will do the square root of 12 quite easily. It'll either A, give us back the square root of 12, or B, give it to us in a simplified form. And the yellow calculator will tell us that this is 2 square root of 3. So for us here, the square root of negative 12 is 2i square root of 3. Questions on this here? Now, are both places here divisible by 2? So we can divide it out. Well, 2 divided by 2 is 1. Plus or minus 2 over 2 is 1, so we're just left with I square root of 3, comma, negative 1, 1, 1. Questions on this here? Questions on any of this here so far? Now, the reason we're able to do that, and kind of what we're not saying, is this here. What I'm really doing is saying 2 over 2 plus or minus 2i squared of 3 over 2, because we can split that fraction apart. And in the first case, 2 divided by 2 is 1. This 2 over 2 is just 1. So we get to this here. That's another way to look at this. Now on the ACT, they might sometimes put their answer in this broken out form. An example of this would be saying 14 plus or minus 15i square root of 3 all over 2. Will all three numbers divide by 2 evenly? No. But what they'll do is say 14 over 2 plus or minus 15I square root 3 over 2. They'll break it up like this here. Just have two separate fractions, because the first one, 14 over 2 is. And give that as the answer. Because sometimes they'll split it apart like that. Now, a little bit different case is, say, and again, I'm just making these up so that it works for this problem. It was 6, and we split it apart, 14 over 6, plus or minus 15I square root 3 over 6. Well, it's kind of like we just did. 14 and 6 do have a common factor of 2, which would simplify the 14 to 7, and the 6 to 3. 15 and 6 have a common factor of 3, so it'd be 5I square root of 3 over 2. So there are cases where we could have the answer simplified to this form, where the denominators are different. I would just take the first one. This here would be fine with me, because unless you can simplify by the same thing, make it nice, that's fine. But this way also you know that this is technically the right answer. It's just we had to split it apart to get there. Questions on this so far? Questions on anything we've covered so far? Okay. This here, we've already seen, the complex conjugate theorem. We've already talked about this before. And it's really saying if A plus BI is a solution, its conjugate A minus BI has to be a solution. If one's a solution, the other has to be also. I like the complex conjugate theorem. So we have a few that are just like the ones we did in the last section with radicals. Write a polynomial function of least degree that has rational coefficients and a leading coefficient of 1, where the zeros are 2 and 3 plus I. Same exact thing. So for this here, it's saying that x is equal to 2 and x is equal to 3 plus I. But it also means that what? X is equal to 3 minus I. Now we need to solve for these here. So here we can subtract 2 from both sides. Minus x minus 2 is equal to 0. Here, because we got it equal to 0 already, that's all we have to do. For the next one, so we're going to need a minus 3 from both sides, yes? Telling us x minus 3 is equal to I. Then what do we need to do next? Questions on this so far? What's the only difference between the one we just did and the next one? The I term is what? Because the first one is positive, the next one's negative, yes? So most likely the next one's going to be what? X minus 3 plus I. So we could do that and just say, I mean the next one. Because the only thing we're doing is changing the radical, or here the I term, from positive to negative, which means when we get it back equal to 0, it's going to change from negative to positive. They're going to be opposite signs. And if we worked it out, minus 3 minus 3, x minus 3 is equal to negative I, which means we have to add I to both sides, and voila, we do get that there. Does that kind of make sense how that works? So it is somewhat helpful, and especially if we see that pattern, we solve one of them, we technically have the other one as well. And again, just like we did with radicals, we're going to multiply these. One more time. Together. And again, just like we did with radicals, always multiply the conjugates first. Always multiply the conjugates first, because it's going to make it easier to work with. So we're not going to mess with x minus 2 yet. We're going to multiply these two out. So x times x is x squared. X times negative 3 is negative 3x. And x times I is plus xi. Then we do the same thing with negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 3 is plus 9. And negative 3 times I is negative 3i. And lastly, negative I times x is negative xi. Negative I times negative 3 is plus 3i. And negative I times I is negative I squared. Okay? I'm just writing down the x minus 2 because we know it won't change. Because the next big step is to combine like terms. Yep.
Nothing difficult, I just wasn't processed. How's analytic go?
Yep. And as crazy as this second part looks, it's almost as crazy how simplified this will get.
Yeah, it's like
Because if we look at this here, so xi, negative xi, that is 0. Negative 3i plus 3i is 0. Now we do have one I term left, yes? Negative I squared. Well, I squared is what? Negative 1. I squared is negative 1, yes? So if we have negative 1, what is this really? Plus 1. I squared is one of the ones that shows up the most out of any of them. The graphing calculator will do I squared quite nicely, because you can do negative I squared, the graphing calculator, hit enter. It'll tell you that it's 1, positive 1. So we have this here. So if we combine all that's left, so we have x squared. Negative 3x minus 3x is negative 6x. 9 plus 1 is plus 10. Last but not least, we do it one more time. X times x squared is x cubed. X times negative 6x is negative 6x squared. Negative 2 times, x times 10 is plus 10x. I about scooted over to the next one. Now we're going to do the same thing with negative 2. Now what you can do with this here, and what I'll sometimes do, is kind of tier step it. So negative 2 times x is negative 2x squared. I'll line them up. Negative 2 times negative 6x is plus 12x. And negative 2 times 10 is negative 20. So we'd have x cubed minus 8x squared plus 22x minus 20. And that's it with that there. Any questions on any of this here? We'll finish this up tomorrow.